Be happy and then just shatter all your hopes and dreams, huh? No, unfortunately, no. So
I swear to God.
here we go. Here we go. Look at this.
Oh, no.
Look what we get to do. Oh, we get the indignant. You have to remember each of these instantaneously. Instantaneously. So 30 degrees. Does anybody remember how many radians that is?
What is it?
Pi over 6. So this is equal to pi over 6 radians. What about 45 degrees? Pi over 4. 60 degrees, pi over 3. There you go. 90 degrees, pi over 2. What do each of those look like on the unit circle? Well, there's 30 degrees, there's 45 degrees, there's 60 degrees. So there's pi over 2, there's pi over 3, there's pi over 4, and here's pi over 6. Fantastic. What about pi? How many degrees is that? That's equal to 180 degrees because pi is all the way to here, which is the same thing as 180 degrees. You're always measuring from the positive x-axis. What about 3 pi over 2? How many degrees is that? It's all the way to there. How many degrees is that? 270. So there are certain things about the unit circle that you just have to memorize. You just have to memorize. And when I say unit circle, I mean this. Unit circle means circle of radius what?
1.
Circle of radius 1, exactly. And what is the 9-letter word that you need to remember the relationship between all those trig triangles? Do you remember? Sarah?
Well, I did an anagram, all students take calculus.
You can do that, but what's the one I want? No. I'm not saying it's wrong. I'm just saying I want to unify around one in particular. Anybody remember? SOHCAHTOA. There we go. See, you know it. So there's SOHCAHTOA. So what do you see here? The OH, the AH, and the OA are the important things because that tells us sine, cosine, and tangent. And in terms of a triangle, there's theta. This is your adjacent side, there's your opposite side, and there's your hypotenuse. In a unit circle, the unit refers to the radius, which is going to be the hypotenuse of these triangles. So if I have this hypotenuse, here's the hypotenuse, here's the height, and here's this. There's your adjacent, there's your opposite, and there's your hypotenuse. In this diagram, O is equal to y and A is equal to what? What is A equal to? If this point right here is xy, the height is y, what's the distance to the right? X. And h in this case is equal to what? What's the radius of a unit circle? 1. So if you fill those in, what does sine tell us it is? This SOHCAHTOA, what does it say? Sine is opposite over hypotenuse. So sine of theta is the opposite side. What's the opposite side? Y over the hypotenuse. But what is the hypotenuse length? 1. Well, what's y over 1? Oh, that's where that comes from. Same thing for cosine. Cosine theta is equal to x over 1. So what is that equal to? X. So that's where sine and cosine come from. That's where sine and cosine come from. Okay, so what does it mean you have to be able to do? Well, you're going to need to know what these look like. That's the first thing. It starts at the origin. Thank you. It starts at the origin. Excellent. Nice. Okay, what about sine of pi over 2? What's the sine of pi over 2? Sine of pi over 2. You need to know this cold. Think about it. What's sine? Raise your hand when you got it. Sine of pi over 2. Sarah?
90.
What's the biggest value sine can be? 1. What's the smallest value sine can be?
0.
So let's put the boundaries up there. So here's the maximum sine can be. And where's the lowest one? Oh, it's right here. So what's sine of pi over 2? 1. And what's sine of pi? 0. So it ends up doing something like this. So you need to be able to graph this really nicely. So it goes down here, it goes up there, it goes up there, and it goes down there. So what does it look like? Is it straight lines? No, it's going to be nice curves. It's going to be nice curves. It's going to be nice curves. You graph sine. So how did we get sine of 1? Well, what triangle is that? That's sine of pi over 2 is the triangle that's right here. So if we see this triangle right here, it's getting closer and closer like that. What's the height of that triangle? Excuse me. When it gets to here, it's the height of 1, right? How tall is this right here? 1, right? What's 1 over 1?
1.
Opposite over hypotenuse. Opposite over hypotenuse. So sine of pi over 2 is 1. Sine of pi over 2 is 1. So amplitude, midline. What's the midline of this function? What's the midline of this function? What's the middle line, Maggie?
Y equals 0.
Y equals 0. That's the middle line of the function. What's the amplitude? And what's the definition of amplitude? It's the distance between the midline and the top or bottom point, because it should be the same, right? It should be the same. So in this case, what's the amplitude? 1. What about the period? Period is what? The 2 pi. It's 2 pi. How long does it take to do one complete cycle? 2 pi. If you started there, it's still 2 pi. It's 2 pi each time. You would need 2 pi distance replicated to graph this for eternity. Okay, that's sine. What about cosine? What is cosine of 0? 1. Cosine of 0, so we did sine here in red. Let's do this one in blue. Cosine of 0 is 1. And does it have a similar shape? Yeah, and it's going to go down here, here, goes up here, goes like this, kind of goes like that. So here, here, there, and there. And then you carefully draw your curves. There it is. So what can we theoretically do with this? We will be talking about the relationship between them. But yes, the derivative of sine is cosine. That is correct. So then does it keep on going? It sure does. It goes down. Yay. They look really similar.
Are you just supposed to know that cosine of 0 is 1?
No, you're supposed to know it based on the triangle. So let's look at the triangle here. So if you have a unit circle and you have 0 degree right here, what is cosine? Adjacent over hypotenuse, right? Agreed? As this becomes smaller, hypotenuse stays 1 and adjacent becomes 1. What's 1 over 1? 1. That's why cosine of 0 is 1. What's cosine of pi over 2? 0, because it's 0 over 1. What happens to this triangle as it gets higher? Well, it goes like this, right? There's H and there's A. Sorry, H is not there. I'll zoom in a little bit. Draw another triangle here. See this one right here? There's H and A is at the bottom here. As this gets higher up, what does the adjacent side get? It's smaller and smaller or bigger and bigger? It's smaller, right? It goes to 0, but the H stays at 1. So it's going to be smaller over 1. Goes to 0. Cosine of pi over 2 is 0. So here's the thing you have to memorize first. You have to memorize this for the base functions. For sine and cosine, the period is 2 pi, the amplitude is 1, and the midline is y equals 0 for those two functions. You have to know those things. You have to know those things, because what are we going to do with each of those values? We're going to play around with them. We're going to play around with them. So we're going to play around with them in this form right here. Do you remember point slope form, everybody? What was point slope form? Tell me what that was. Y minus y1 is equal to x minus x1. If you have something in point slope form, you automatically know a point in the slope, right?
Yeah.
It's a specific form. Is it the only form you can write a line in? No. You can write it in slope-intercept form, right? Doesn't tell you quite as much. This right here is the general form for graphing these trig functions. General form. General form. Y equals a sine kx minus c plus d, and y equals a cosine kx minus c plus d. It looks nasty, but if the trig function is written in this form, you can graph it really easily, relatively easily if you do it carefully. But it has to be in this form. Why? Because if it's in those forms, look at what it tells us. It tells us these 4 things. This is so huge and important today. Huge and important. If you have A, you know what the amplitude is, the distance from the midline to the max and min. C is the horizontal shift. D is the vertical shift. And the period is 2 pi over k. The period is 2 pi over k. Meaning, what? You did this in pre-cal, yeah? Mm-hmm. If it's in this form, are they always going to be in this form? No. But if they are, you can use this form to graph. So what do I mean? Let's look at this one right here. So in this case, what's the A value? Can someone lead me through this? What's the A value on this one? So the A value on this one is 5. What's the C value? What's in front of the X? What's in front of the X? Oh, excuse me, no, that's, sorry. What's the C value? Negative what? Negative pi over 4. What's the D value? 5. And can you see what the K value is? It's the number in front of X. 1. So what does that tell us? If K is 1, the period is 2 pi over K, so the period is 2 pi. Okay, where's the midline? And I don't know why there was a weird twang on that, but where's the midline on this? If the D value is 5, where's the midline? y equals 5. Y equals 5. So we go to 5 here, which is going to be right about here. And that right there is our midline. So what's our amplitude?
Why is that midline? I thought D was a vertical.
Vertical, exactly. So where's the midline usually? 0. What's 0 plus 5?
Oh, okay. Vertical shift.
Vertical shift, exactly. What's our amplitude? 5. Our amplitude is 5. So how far up maximum does this trig function go? And minimum?
0.
Yes, so let's put our bounds up here. We know it goes all the way up to here, and it goes down to here. Excellent. Horizontal shift. Usually sine starts at the origin, right? We now know it's gone up 5. Does it go left pi over 4 or right pi over 4?
Right.
It goes to the right pi over 4. Here's why. No, it goes left pi over 4 because it's negative. Look, here's why. You have to be really careful about this. When you plug in negative pi over 4, what's negative pi over 4 plus pi over 4? 0. So negative pi over 4 now has the same effect as 0. Negative pi over 4 has the same effect as 0. So which direction do we move it? We move it to the left pi over 4. So where's our starting point going to be? It's going to be right, let's put it in blue, I guess, right here. There's our starting point. So it's going to go up and down and up again. What's our period? 2 pi. Our
Sine. So
yeah.
it start at 0?
No, it doesn't start at 0 because it's gone.
Midline, sorry.
Yes. Okay. So is it going to go up or down from that point?
Down.
What does sine do? Sine goes up, right? And it goes every 2 pi. So it's going to repeat, and then it's eventually going to end up right back here, a little bit before pi, a quarter before pi. So it's going to go up and down. So it's going to go up, and then down, and then down, and then up. So what does this look like? It looks like this.
Oh, so the second point you just drew, they're just estimates, right?
These aren't estimates. These are the exact same shape as we graphed before. We know that it goes, this distance right here is pi over 2. So if you go pi over 2 forward, you're going to get to the highest point. If you go another pi over 2, it's going to get back to the midline. If you go another pi over 2, it's going to get to the lowest point. If you go another pi over 2, it's going to get back to the midline. That's what we knew from the original graph. The only thing that's different now is we stretched it this way. Did the period change? Did how fast? No, the period doesn't change. What did the period stay? 2 pi. So it goes up and down. Now everything else, what can I do with this now? If I wanted to graph the rest of this, what do I do? Continue it, right? So let's just see, what is it going to look like? I could take this right here, copy it, and go doot, paste it, and then move it over here.
What would cause it to stretch out?
Which way? You mean to the left and right? The k value. What's the k value on this one?
1.
So if the k value is anything other than 1, it's going to somehow change the shape, which we'll get to in a second. The next one will have that in there.
Oh, this is kind of like the basic transformation.
Yes. -4. Exciting. Y equals -4. What's our amplitude?
2.
So it goes up. What's the highest value we can go up to? You can go all the way up to here. It can't go past it, and it's going to go down to what? -6. So we go up to up to -2 and down to -6. Nice. Okay. Let's figure out where it starts. Does it shift left and right at all? No. So do we know where it's going to start?
Yep.
Yeah. Is it? Careful. This is cosine, right? Where does cosine usually start?
At the top.
At the top. So where's it going to start now?
At the top.
At the top.
At the -2.
And we can figure that out too because we can plug it in. What's cosine of 0? 1. 1 times 2? 2 minus 4? -2. So does it start there?
Pause. Can you do the very last thing you just did again?
Yes. What is cosine of 0? Form. And then you identify all the values. A, C, D, and K. I know you don't like it. So in this case, what does A equal? What does your C equal? 0. What does D equal?
1.
And what does your K equal? Pi over 2. So that tells you that the period is 4. So in this case, it's sine, and also it's negative, so that just is going to flip it over. It's just going to flip it over. Does this shift left or right, Liam? So it's going to go down because it's the opposite of sine. Sine goes up from that point, so it goes down and then up. So it follows this path right there. Follows that path. That. So it goes down to here, and it goes up to here. That's our amplitude. Where's it going to start? You shift it how far, which direction? What's our What's our c value? -1. So that means how far to which direction? What kind of shift?
One to the left.
1 to the left. So instead of starting 1 to the left, instead of starting, where's 1 here? Instead of starting here, where's it going to start?
Over the left.
To the left. And why does it start down there? Because it's flipped over. The negative sign flips it over. So cosine gets flipped over. So usually cosine would start here, right? So if you flip it over, where would cosine start? Down there. But then you move it 1 to the left. So then it goes up like that. It's cosine flipped over. It's cosine flipped over. Okay. Let's look at the last few here just to make sure they get covered. This one right here, some of these you can do have exact answers, some of them you cannot. Sine of theta is 1/2. The sine of what angle is what 1/2? So what you're looking for is a triangle, this triangle. Why are we looking at that triangle? Because the sine of that angle is 1/2. Sine is so, which means what? Sine is opposite over hypotenuse, right? So this adjacent side right there is 1/2. What's that angle measure? You just need to remember what that is. Anybody remember what that is? What angle measure is that? Base is pi is 1/2, height is √3/2. Here's more of it to scale. It's a lot higher than that. It looks like this. It's 60 degrees. So this right here is 60 degrees, but I like radians if possible. What's radians going to be? Pi over 3. So some of these are exact, some of them are not. Like this one right here, we're not going to be able to do exactly, but we can isolate theta. If we want to isolate theta, what do we subtract first? What do we subtract first? 1. So you have -3 sine of pi over 4 theta equals what? You subtract 1. Now what do we divide by? -3. -1/3. And then what do you do now? Do you remember this from pre-calculus line? What do you do now? How do you undo sine? Inverse sine. So pi over 4 theta is equal to sine inverse of -1/3. What do we multiply by now? What do we multiply by now? 4 over pi. So theta is going to be equal to 4 over pi times sine inverse of -1/3. Is that a trig value that you can memorize? Not really. So if I ever asked you for the decimal of this, what would you need? You would need a calculator to do that right there. But have you isolated theta? Have you isolated it? Absolutely. Yes.
So for the
What do I subtract first? What do I subtract first? Someone, Mikey, what do I subtract first?
2.
So I get 4 cosine of 3 pi plus pi over 3 equals what?
-1. No.
Yeah, you got it. Equals what? Negative? No, negative. You subtract 2. -3. What do I divide by now, Mikey?
The 4.
Yeah, so you have cosine of 3 theta plus pi over 3 equals -3/4. What do I have to do now? I've isolated cosine, so I have to undo cosine. Yes, Sarah? So you know that 3 theta plus pi over 3 is equal to what?
-3 over 4.
Well, no, it's cosine inverse of -3/4. What do I subtract now? So you have cosine inverse of -3 over 4 minus pi over 3. And now what do? And then you are done. Is it longer? Sure. Would you have to use a calculator to get the exact to get the decimal? Absolutely. But is this the answer? Yes, it is. That is the answer. You have isolated theta with goes up to 4 and down to so it's going to be what? 3. So we have the c value and we have the k value. What's the c value going to be? Oh, it depends on what function you pick to start with. What function do you want to use? If we use sine, that means it's going to be negative, right? So a has to be not 3, it's going to be what? So we're going to use sine in this case, so it's going to be -3. So what's the c value going to be? 0. It's not going to move left or right. Oh, how do we find the k value? Well, the period is 2 pi over k, right? Can you tell me what the period is on this? How long does it take to go? 8. So 8 equals 2 pi over k. 8 equals 2 pi over k. So k is going to be? Pi over 4. So can we build this? So we think a is going to be what? Negative what? 3. Figure 3. What? sine of pi over 4 times x minus 0 plus what? All done. Could you do this differently? Could you do it with cosine? Yeah, sure. Absolutely. Could you move it to the left or right? Absolutely. There's actually an infinite number of ways you could do it. Infinite number of ways. See you, kids. Have a good weekend.